Hello and welcome to this guide for how to put together a scaled form of the steel beam and steel pipe production. So in this build we're going to be producing 2160 steel pipes per minute, and we're also going to be producing 810 steel beam per minute. Now both of these can't run at full tilt at the same time, but if we just need steel beams, then this can run at that rate in this whole factory, or it can of course produce this much steel pipe. But yeah, if both are in demand, then these rates will be cut in half. These are the input materials that we're going to be using. So we're only going to be needing 1163 iron ore. We will be needing 2160 coal per minute, and then we will be sort of using some alternate recipes as well. That I'll explain, but yeah, you will need to unlock them if you also want to put together this build. I have a guide on my YouTube channel for how to get all of the hard drives pretty easily. So before we look at what we actually did, let's look at what we dismissed. So there's another fairly good build based on petroleum coke, which is pretty good as well. In that case, I think this is a mistake. This is the yeah, that's a different one. That's compacted coal. Well, this up here is compacted coal. So what you can actually do, I don't think we fully looked at this, but yeah, with compacted coal, with some of these input materials, you can actually produce a decent amount of, like the same amount of steel ingot, but instead of needing water, you actually end up needing sulfur, and you also end up needing a lot more iron ore. So that's why we dismissed this one. The petroleum coke one, which is of course not sort of correctly noted down here because it's still based on sulfur, but the petroleum coke one is pretty good as well. It's just that you need petroleum nearby, which we don't have in this particular location that we picked. Then the other one that you of course can do is you can just sort of use the sort of basic recipe, but then with the sort of 2160 iron ore and coal that we have available in this location, you actually end up producing less steel ingots than we are. So instead we're going to be using a build where we use water as well as iron ore to produce iron ingots, and then we're going to be turning those iron ingots and coal into steel ingots. So yeah, that's going to be the aim. Alright, let's get off our perch here and delete this. So we have sort of put together everything already. The only thing that's missing is the, like, making it all work, which is sort of the exciting part. So let's do that. Now we start over here with the what do we call this? The pure iron ingot. So that's the first step. So this is where we are getting all of our inputs. So we're getting all of this water, we're getting all of this iron ore, which is actually sort of 2 full belts of iron ore. We're not going to need all of it. And then we're getting 3 full belts of coal. The iron ore is being mined over there, and then the coal is actually being mined up there. So you can see that we've drawn coal all the way along here and then sort of grabbing it from over there. I'm not going to show you exactly what that looks like because it's just, a fairly boring mine. So, and the water source is down here. So we actually built a very nice sort of quay over here with all of these water extractors lined up. So we have 7 water extractors for 720 water per minute, which means of course that we need 2 pipes. We're not going to be needing all of the water, but we'll need most of the water. Here we need more than just 1 pipe, which is why we have 2 pipes. So yeah, so let's connect this pipe into here, and then all of these should actually start to receive, well, we actually need to connect this into here, of course. So you can see that the water is now getting pumped through there, and this is starting to get water. So then the only other thing that is still left is that we need to put down a splitter. Now usually it's a better idea to put down these splitters before you put in the pipes. So in this case we chose to put the pipes on the bottom and then the iron ingot on the top. Now did we actually get this wrong? Because that would suck. Yeah, that splitter went in wrong. So let's try that again. This is of course one of the really annoying parts of this build, is that you have to get lots of things right. And that's not always easy. Alright, so let's connect that into there. And then we'll have to figure out how to get all of those materials over here, which we'll do in a minute. Alright, so then this goes into here. Right, so now we will want to put, actually it'll be easier. So 1, 2, I think it'll be here. And then we'll go into the middle here. So I think this will be easier to do rather than anything else. Okay, so that's the iron ore that's coming. No, I don't think I put this quite in the right place, because we would need 1, 2. Okay. All right, let's see. We can probably connect that through. Yep. All right. Cool. So then we just need to connect this to this one, this to here. We can get rid of this now. Oops. Just for aesthetic purposes. Okay, and then we connect this into there, and then this into here, and then we should see that this has iron ore, and it's going to be producing iron ingots, which is a great situation to be in. Now, we can actually look here. So this is not getting water for some reason. Because I forgot to actually connect these things through. So, because there's quite a few of them, I'm just going to do that, and then I'll be back and continue with the guide. We have just connected the water in for all of these refineries, so you can see that all of them are getting all the materials they need now, and we have a whole bunch of production going on. Now I suspect that in this particular case it's just right. So at some point this first 720 belt of iron ore will run out, right? It can support 720 divided by 35 number of belts. Now that's not quite 720, which is why we have this somewhat more complicated interchange here, right? Where we essentially need to, we still get about half the output of this one, sort of coming through here, being able to feed that one. But then, you know, they're still not going to be able to put the full 720 from here onto that bottom belt. So we need actually that second time sort of putting the materials down. And of course, in these sorts of locations, it will take a little bit of time. Towards the end of sort of a long chain of input, it's going to take a little bit of time as the input buffers for these refineries are actually put in. So if we look at what's actually going on here, we have 34 refineries, which is a little bit more than we actually need. I think it's about half of a refinery more, which is why we went to 34, not 33. And they're going to be getting enough input materials to produce a little more than 2160 iron ingot per minute. They're not going to be able to put more than 2160 iron ingot on the belts because we only have 3 output belts, but they will be capable of producing a little bit more. That's fine. And they also, of course, consume water. So now, if we look at the output line over here, so you can see that all of these iron ingots are being produced and are on these belts. So the other thing that you can see is that, of course, we're going to need more than one 720 output belt. It's not going to do, so that's why we have this stack. And you'll be able to see that this one here will actually get to the second output belt. Now in this case we actually have to feed because these are not going to be able to exactly put down a belt of 720 iron ingots, we actually have to take the previous one that's you know, a little bit more and actually refresh it down a little bit. So that's why this is here. And then we actually also, I just realized we probably have to pull some down from the top, because at this point this is only going to be capable of actually sending 720 down the line, and of course here it's going to be a little bit less than 720, but I think that's a detail that you know, we need to figure out at some point. It probably means that we need essentially a fourth belt that can sort of stock up some of the bottom belts here. But yeah, so each of these belts is only actually going to be down by about 5 iron ingots, so I'm not that worried about it. Okay, so let's put this one here. So we can connect this output together. Of course, this output then can make its way over here, and you can see that we draw materials backwards along here. And then we'll also connect these in here. Oh boy, that's not really what was necessary. So we want this to come here and this to come in here. What I'm going to do for 1 minute is actually put that belt in that is going to be there to make sure that at the end all of these belts here have 720 on them. So I'll show you how I put that together. 1 minute. Okay, so we have fixed the problem. What you can see here, right? So between each of these belts, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's the case for all of them. 11 feeds like one of these belts. Now, 11 actually produce 11 times 65 produce 715. So 5 per minute is going to be missing from this conveyor belt here, right? Which is where this last one comes in now. Of course, this is not sort of getting anything right now. I don't actually know why this isn't drawing. Okay, that was just badly connected. Okay. So this last belt here, the purpose of that is to essentially carry enough material to put 5 into each one of these. So what's going on with you? Right, I see, because the belt is full. Okay, so what you can see here is that we are taking this top belt and using it to top up this belt just before it gets lifted there, right? And we're doing the same down here as well for the other belts. Just before the end, we sort of use it to refresh that belt in the ground. So this adds the 5 per minute in once these are running at full rates. And then of course this belt is also going to be 720 per minute. And then we have that exact same arrangement at the end here as well. So sort of refreshing that last belt. Okay, so the next step, now that we have the iron ingots, we will need the coal to put into the what is this called? The foundry to produce steel ingots. And what you can see here is that we're using an alternate recipe called solid steel ingot, which uses the iron ingots and coal to produce steel ingots. So not only do we get a very nice multiple here, right? Like 35 iron ore produce 65 iron ingot per minute. Usually it's 1 for 1, so that's a lot better with these. And then usually the recipe is 1 iron ingot, 1 coal produces 1 steel ingot. Actually, that's a lot better here because 40 per minute of the iron ingots produce 60 per minute of the steel ingot. And that's why you can see that we actually don't need a lot of iron ore and we need a lot less iron coal to actually produce essentially 3,240 steel ingot per minute, which is a lot of steel ingot to produce. Usually we'd only be able to go to 2160, so we're actually getting 50% more. And if we weren't coal limited, of course we could, you know, go a lot further with this iron ore as well. So the way that this one works is that we have sort of two sort of foundries facing each other, and they're sharing input material here. And that's just to limit the, limit the sort of how far back these go. So for that, we just need to feed it coal. Oops. Just need to feed it coal. Did I get this wrong? Oh, I think I put a merger in, which is not great. Right. So yeah, we just need to feed it this coal and this these iron ingots. And oops. Then we also need to, of course, connect this through to here. And then we need to get these materials in. Alright, so I don't have enough of that. I'll show you, that gives me a chance to actually show you how we solve the material problem. I have a guide for this as well. So in this way, you can imagine that this would take like lots of trips back and forth to our home base, but instead we have hooked up a drone delivery system where at the home base we sort of planned and counted all of the materials that we needed to build all of this, and then just slowly over time got these drones to deliver it. And then we have, these programmable splitters that sort of separate out the materials into these. But if you want to know more, there's a guide on my YouTube channel. You just sort of search for something like never ran out of building materials or something like that, and then you'll be able to find it. So yeah, that's pretty cool. And it's meant that we've just been able to be over here and build for the most part. All right, so now that all of these are working, we actually have to connect the output. And then the way that these are arranged, oops, I got that wrong. The way that I've arranged this is that we aggregate the output to here, right? So we'll see all of the steel ingots arrive here. And that essentially means that we can expand that as far back as we want, and we don't run into any problems on the input here with like clashing materials. Otherwise I'd have to find a way to get the steel through here, but instead we essentially start anew because we don't have those outputs. But yeah, the other thing to sort of show you is, now one of the things you want to keep in mind is that of course we have to refresh these materials. So there are actually 18 smelters that can run off one full belt of coal and iron ingots, and then you have to refresh those two material lines. So what you can see is that we just have like the sort of other material that we have available just going backwards on these two foundations and sort of merging into these production lines after 18 foundries. And that happens in the same way at the back here. The other thing that you can see is that 12 of these foundries actually produce one full belt of steel ingots. So at that time we sort of take it out and then start a new belt. You can see a second belt starts at the back there, and then a third belt sort of gets merged in here, and we actually end up with 4 belts plus a bit. So we actually have 4.5 belts of steel ingots, and if you do the maths on that, you'll find that it actually produces the amount that we were saying here, so the 3240. So if we go 750 times 4.5, it's a bit more than 4.5 or a bit less, I'm not 100% sure, but yeah, it's going to be 3240 steel per minute. Okay, so this output steel then needs to be brought to here, and then of course we also need to oh wait, this is going to the wrong location. It actually needs to go to the top, so let's do the other one. Okay, I'm gonna delete this. Right, so let's draw this forward all the way to the front. Usually I put it to like well, we can only really put it to here, unfortunately, and then we can connect this into there. Okay, so that's the steel that's functioning, and this just means that, you know, the one that isn't running at the full rate will be at the top, so it's the last one that will actually be used. which is precisely what we need on the back. So 1, 2, 3, 4. I think that should be enough. So let's connect this to here and then this into here. Then we can connect these other materials through. Okay. That to there and this to here. And then finally what we need to do is we need to actually have this one here. So it's going to be 1, 2, 3, 4, 5, and 6. And then what we will also need to do here is just line this up. Then we need 1, 2. Okay, this goes to here and that goes to there. Okay, and then we have a huge amount of steel getting delivered. Okay, so then the next step is that of course we need to produce the 2 output materials. So what we have here is that the first step is that we're actually producing steel pipes here. So we are going to be sinking all of the 3240 steel ingots into steel pipes, which means that we can produce 2160 steel pipes per minute and actually 108 constructors. And we're using the standard recipe here, where 1 steel pipe costs 1.5 steel ingots. And you can see that there's a ridiculous number of these constructors available here, which is a lovely sight. And the way that we have, again, done this is we have 2 constructors sort of facing each other, taking input materials like this. Oops. So we'll connect this into here. And then the output, again, is getting first sent to the back and aggregated, and we'll see that come through. And then, of course, here is where it will all sort of end up. So what we'll do here is we'll do something like this. And then we need this one here. Okay, 1, 2. Going to there. So that's all of the steel pipes. So something to keep in mind is that you will have to essentially refresh the input material. I think it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so 24 of these constructors can be fed by 1 full belt of steel ingots. So every sort of 12 you will have to essentially take one of these input lines and refresh the bottom input line. And then it actually takes quite a bit of, it takes about 36 of these constructors to produce one of these output lines, because we only take the output from one of these. After 36, we just merge out this steel pipe, and of course, over time, as more of the input buffers will get saturated, we'll actually see that this will be producing a full 720 per minute. But yeah, and then this essentially collects all of the output for the second belt, and then we have our third belt of steel pipes coming through here. Now, if we look at this, of course we don't have steel ingots, but that's because these input lines are still being saturated here. These are still getting built up to 100, and then eventually it will all flow to the back. So yeah, that's pretty good. Now, once we have produced these steel pipes, the plan here is going to be that we deliver these to wherever they need to go through these drone ports. The reason for using drone ports is because I don't feel like drawing trains. They're very long. And we are going to be, as the next guide, we're going to be putting together a highly scaled battery production. So then we're not going to have to worry about batteries at all. Now on this side, we're not going to actually provide batteries. So this is purely a pickup port. It's not going to be able to deliver. So wherever we want this material, we will have to make batteries available there. So yeah. So the way that we connect these here is that we just draw them. Just draw them into the input lines. And I'm not even going to put an industrial storage here. which I have done in the past, but it's just not going to be necessary. We're not going to be spending any time at this location. It just needs to be producing its materials, and then I'm going to be perfectly happy with that. Okay, and then we just need to cable these two into here. And then we have 3 drone ports here that will be receiving steel pipes at a rate of 720 each per minute. So yeah, that's a pretty good development. Now we have all of these belts actually getting materials. Okay, so then the next step is that we're actually going to be splitting the steel ingot input, right? So we're going to have 2 production lines that all can sink all of this input. So it just depends on which particular production line actually needs to be running at a given time. But that's for the steel beam construction. Now the steel beam actually takes a lot more input material to be to produce. So it actually takes 4 steel ingots rather than 1.5 to produce 1 steel beam. So wherever possible, we want to use steel pipes instead of steel ingots. So there's 3,240 steel ingots. Actually, it's only going to result in 810 steel beam, which is just a little bit more than 1 full belt. So this other than that, this works in a very similar way. So we have these constructors that are producing all of these materials that are the steel beams that we actually want, that are connected through like this. And then of course we have these sort of refresh lines that we can connect in through here. The only difference for this one compared to the steel pipes is that the location for the refresh is slightly earlier, so we actually only can feed 12 constructors off of 1 720 per minute steel ingot line. So you have to keep that in mind. And then the output, of course, is just 1 belt. So in total we have 54 foundries here, and it takes 48 foundries just to make 1 full belt of these steel beams. Now, we're not going to be able to produce the steel beams at full rate because, of course, the steel ingot is currently being shared by this production line as well as this production line, and the steel pipes are they're not saturated yet, so that'll have to happen. But the assumption is that I'm only going to need either steel beams or steel pipes in the future. So, we just need essentially 1 of these to be able to sink all of the steel ingots that we can produce. Okay, so then on the output here, which I'll just show you now, is that we have the usual method of collecting the output backwards as a starting point. So that we can essentially keep scaling backwards if we so choose. And then it comes back all the way to the front, and you can see that we have steel beams right there. And then we also need to click this here, so it'll work in a very similar fashion. We'll just put 1 of these here and then put this in. I don't know why it's trying to do something really complicated there, but it's okay. And similar to the steel pipes, we're going to be delivering it into this drone network. So in this one here, we are going to have essentially 1 720 per minute belt of steel beams that will go into here, and a very small number of steel beams that will actually make its way into here. It's not going to be a lot at all. It's only going to be the output from 6 of these, and that's about 90 per minute, so it's not going to be a whole lot. But yeah, that's how this crazy scaled steel production line works. I'm pretty proud of it. Now we have steel pipes and steel beams available at scaled rates wherever we want. I also am very pleased with these floodlights. And also like sort of this open cut or open factory for the steel production, which is very cool. But yeah, you can see that the bottom belt here is running at full rate, and then the top one isn't always running, which is because we only actually need a little bit more than 1,000 iron ore per minute. And then you can see that, of course, these lines are going at full rate most of the time. And you can see that some of this refreshing materials come through here. I think some of these are still getting the input buffers filled up. We can always check a little bit and see if any of them are not working. I think all of them are working now. And then you can also see that all of these are working at the moment as well. So that's a pretty good outcome now. So yeah, I'm sure there's some mistakes in here that we can correct at some point. But for the purpose of the guide, that's all I have for you. So thank you for watching. Until next time, bye.